We've got 5 people receiving sweets. They've got to have different amounts, and essentially, the older they are, the more sweets they get. So let's take a look at the smallest number of sweets that could be obtained in theory. 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. So what that means is that the most that the oldest person could get would actually be 10. Then I would change this to 20. So oldest receives less than or equal to 10. Something you can also see is if we do 2 plus 3 plus 4 plus 5 plus 6, then this is equal to 20. And so the oldest must receive greater or equal to 6. There's no way that they could receive 5, for example, because then um, they'd be receiving the same as somebody else. So now let's take a look at the configurations then. So how many different ways can they share the sweets? Well, we could, like I said, have 1, 2, 3, 4, 10. And now I think it's a case of systematically work on our way down. So imagine that they have the oldest gets 9 instead. Then the only one I can increase is going to be the 4 to 5. And the rest would stay the same because we can only increase the others by 1. And if I increase in the others by 1, it would be the same as somebody else. So that's 10 and 9 sorted. Right, what if they receive 8? Now, one thing I could do would be to increase the 5 again to 6 and keep the others the same. Or I could keep the 5 as it is and increase the 3 by 1. I can't increase the 1 and the 2 by 1 as for the same reasons as before. So that would also work. If those are the only two that work for 8. Okay, what if it is 7? Now I can, well, I can't actually increase the fourth person's one, but let's say they've got 6. Actually, maybe I'll just, no, they can't have 1, 2, 3, and 4, of course. So let's try 6. Then I'm up to 13. Could I get, no, I can't then have 5. I could have 4, 1, and 2. So that would work. Or I'm just trying to make sure I work for this systematically. I've dealt with if it's 6, I could have, see, that is the only way. I can't have the fourth person having 5, the third person having 5, because then I'd have to make up 2 for the other 2. That's not going to work. But I could have 5 here, maybe. And then 4. Now I'm up to 12. Then I could have a 3. That would also work. Yeah, this is one of the trickier ones, but there's just going to be 2 options for 7. And then as we said before, for 6, this works if we do 1, 2, 3, 4. No, sorry, not 1, 2, 3, 4. 2, 3, 4, 5, 6. Okay, so there's only one way we can do it when the oldest gets 10, one way when they get 9, 2 ways when they get 8, because we can either um, increase the fourth person's one more than up here, or we can take the third person and increase that one by 1. For 7, we have to be a bit careful. So we can either have 6 or 5 for the fourth person. Then the third person has to be 4. There can't be 5 here because you wouldn't have enough for the first and the second. For this one, you have to have 4 again because 1, 2, and 3 won't work. Once you've got the 4, you need to increase the second person's relative to the previous example. Those are the only ways. And then for 6, there's this one way. So overall, there are 7 ways. Be really careful working through them. This is the list. Well done.